Hello everyone. Now we are going to see about a concept of searching and sorting techniques. First we will see about the linear search. So linear search is a simple search algorithm. Here the search is made over all items one by one. Every item is checked and if a match is found then that particular item's location is returned. Otherwise it will return -1. The other name for the linear search is sequential search. The routine for a linear search is we are passing an argument that list and key. For each items in the list, if the item equal to value, then it returns position. Otherwise, it will return -1. The logic is X is a searching element. We start from the leftmost element of the array one by one and compare the x with the element of the array. If the x matches with an element, return the index, otherwise return -1. So example, in this list, the search element will be 33. So first iteration, the first element is compared with the 33. If it is found, then it will return. It will not found. So then it goes to second iteration. It compares 33 with the second value for 14. Then it will not match. Then it goes to third iteration. Likewise, the 33 will be found at the iteration 7. So it returns the index value. The advantages is it is easier to implement. It will not require sorting. It is suitable for small list of sizes. The disadvantages is time is insufficient as compared to other algorithms. It is not suitable for large size lists. Next, binary search. So binary search, it is a fast search algorithm. It works on the principle of divide and conquer. First, this algorithm to work properly, it requires the list should be shorted. So the procedure algorithm is first we have to initialize the beginning value as a 0 and end value as a number of elements -1. The first step is the element to be searched is considered as the key. The key value is searched with the mid element. If it equals, it returns the position. Otherwise, if the key value is lesser than the middle element, then it goes to left side of the list. So the end value will be mid -1. If the search element is greater than the mid value, then the algorithm goes right side of the list. So the beginning value will be updated as mid +1. So these steps will be repeated until the key value is found. So example, here totally 9 elements are there. So index will be starts from 0 and length of the list end value will be 8. First the item to be searched is 23. So this 23 will be compared with mid value. Here mid value is found at the location 4. So 13 is compared with 23. So it is a greater value. So it goes right side of the list. Again this will be divided. Here the mid element will be 20. Then this 20 will be compared with 23. Then it will be lesser. So it goes to left right side of the list. Then next this will be matched with the location 7. So though here two methods are using, that is recursive method and iterative method. So how the binary searches differ from linear search means binary search is more effective than linear search because it requires less time to sort the array. But the disadvantage is when binary search, the list should be shorter. Then next we will see about the sorting techniques. So insertion sort. So insertion sort is a simple sorting algorithm. So it works similar to the way we are playing cards in the hands. The array is virtually splitted into a sorted and an unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part. So the logic is set a marker for the sorted section after the first element. Then repeat the following steps until unsorted section is empty. Select the first unsorted element. Swap other elements to the right to create the correct position and shift the unsorted element. Advance the marker to the right one element. So this is an example. Here 7852463 it is the given list. We are uh, going to sort a list. First, the marker is set. First, the marker is set next to 7. Then it will be considered as a sorted array. The remaining elements will be considered as an unsorted array. Next, the 8 will be compared with uh, the shorted element, that is 7. So 7 and 8 it is already in the shorted position. Then the marker will be advanced by 1. That is, it goes to next to the 8. Then next the 5 will be compared with the 8. So 5 8 will be compared. Here the position is not correct, then it will be swapped. Then next again this 5 will be compared with the 7. Here also the list is not shorted, so again the 5 will be swapped with the first location. Likewise all the elements are shorted by advancing the marker, as like we are playing the cards in the real life. So, what is the advantages of insertion sort is it is relatively simple and easy to implement. Disadvantages, it not sufficient to operate with the list size of bigger size. Next sorting is selection sort. So selection sort it is an algorithm, and this algorithm sorts an array by repeatedly finding the minimum element from unsorted part at putting it at the beginning. So the algorithm maintains two subarrays in a given array. The subarray which is already sorted and the remaining subarray which is unsorted. In every iteration of selection sort, the minimum element from the unsorted subarray is picked and moved to the sorted subarray. So the steps is first array is considered into two parts, sorted and unsorted. Select the lowest element in the remaining array and swap and bring it to the starting position and change the counter for unsorted array by 1. This is the steps to be followed. So this is an example. First, take the first element 64. Compare the 64 with 25. So we have to swap the 64 and 25. Then these elements will be compared with 25 will be compared with next element 12. Here the minimum element is 12. Again the 12 will be compared with 22. Here also the minimum is 12. Again this 12 will be compared with 11. So the minimum element is 11. So this 11 will be swapped with 64. So this 11 is shorted one. Then next 25 will be compared with 12. Here 12 is a minimum array. Then 12 will be compared with 22. Then 12 is the minimum value. Then again 60 compared with the 64. So 12 is the minimum element in the unsorted array. Now this 12 will be swapped with the 25 and the marker will be moved to right. The sorted array has 11 and 22. The unsorted array has the value 25, 22, 64. Then uh, smallest element is found in the unsorted array. Here the 22 is the smallest element, so 22 will be swapped with 25. Then the sorted element has the value 11, 12, 22. Then 25 and 64, compare 25 and 64. 25 is the minimum value, it is already in the correct position. So the final sorting array will be 11, 12, 22, 25 and 64. How the selection sort will be working is, first in the entire list it will found the minimum value. This minimum value is swapped with the first element in the unsorted array, and then that sorted minimum element is marked as a sorted list. Again in the remaining unsorted list it will found the minimum value, then it will be swapped with the next location. Likewise all the elements in the list will be sorted. So the advantages is easy implementation, which can be used when memory is less. So disadvantage is slower when number of elements are more. Next, we will see about the bubble sort algorithm. So bubble sort is a repeatedly swapping the adjacent element if they are in the wrong order. So this algorithm works by comparing first element with the second one, then second element with the third one, and third element with the fourth one. Likewise, it will be compared. This is a bubble sort algorithm. Then next, advantages of bubble sort is it is easiest algorithm. It is easy to implement. But the disadvantage is it will needs more comparisons and it will be become complex and compared to large amount of data. Then shell shot. So shell shot is a generalized version of insertion shot algorithm. It first sorts the elements that are far apart from each other and successively reduces the interval between the elements to be shorter. So the interval between the elements is reduced based on the sequence used. So the procedure is compare elements that are distance apart rather than adjacent. Calculate the gap for each pass and then select the element towards the right of the gap. So reduce the gap by dividing by 2. So first the total elements in this list is 8. It will be divided in the sense modulo division by 2 it will gives the 4. So here the gap is 4. So the first element is compared with the fourth element, and second element will be compared with fifth element, and third element will be sixth element. So the gap between the elements will be 4. So this 35 is compared with 14, and if it is smaller then it will be swapped. Again 33 will be compared with 19 and 42 and 27. So likewise the gap will be calculated and the elements in that particular portion is compared. If it is not in sorted order, that will be swapped. Then in the next pass, total the gap again will be divided into 2, that it will be divided by floor division by 2. So that it will gives the 2. Here we are comparing the first element with the third element and second element with the fourth element. Likewise it will be compared. If it is in shorter order, it will be leaves, otherwise it will be shorter. And the next part, in the third pass it will be gap will be 1. So as like bubble shot, both the adjacent elements are compared, the list are shorter. So what is the advantages of this shell shot is it reduces shifting operation than insertion shot and it improves performance. So what is the disadvantage? Disadvantage is complexity. So it has more complex implementation compared to bubble shot and selection shot, and it will not be stable. Cell shot is not stable algorithm. Okay. So thank you.